Alright, in this video we're going to go over an example of using U sub and the second fundamental theorem of calculus. So with this equation right here, what we can see is that we can use U substitution right away because it's kind of tricky to integrate this with the x value and a term in the denominator. Let me see if I'm in focus. Yeah. So it's a lot better to substitute in U into this equation and make the integration a lot simpler. So make sure I'm zoomed in. So I'm going to rewrite the equation down here. And we could set u equal to 5 minus 3x. And when we take the derivative of u, it will be du equals negative 3 dx. And what you can see here is that we could substitute in the du for the dx in here. But because it's just dx, we could divide both sides by negative 3. So it only has dx in here. So when we substitute in du over negative 3 for dx and u for the term in the denominator, what we'll get is 2 to 4 of du over negative 3u. And what we can do is we can just bring the negative 1/3 out here. And another thing to really pay attention to is that because originally these values over here, the 2 and 4, they are in terms of x, but we substitute in u for a definite integral. That means there's like a set endpoint and starting point, or set starting point and endpoint. We have to change these values to fit the value of u as well. And how do we do that? Well, we just have to find an equation where the value of u is related to the value of x, and that's what we have right here. So if x is equal to 2, then we can set u, we can find out what u is, which is from 5, and we'll just substitute in the x into this equation, so it's 5 minus 6, which is negative 1. And when x is equal to 4, it'll be u is equal to 5 minus 3 times 4, which is 5 minus 12, which is negative 7. So the new endpoints are going to be from, so the original starting value is 2, and that becomes negative 1. And the original value here would be 4, it goes up to negative 7. And we just, I already factored out the negative 1/3, so we just leave it as u here. Now one thing to pay attention to is that for an integration, you always want to have the smaller value in the bottom and the bigger value in the top. And in this case, negative 1 is bigger than negative 7. And there's this rule for this integration where it's if it's a to b of u, this is the same as negative b to a of u. So u du. So what this means is that, like, let me just do a graph real quick. If you're trying to find the area from here to here, if you go from left to right, you get a positive value. But if you go from right to left, you're kind of like taking away the area, so it'll be negative. And in this case, because you're going from a greater value, from the negative 1 to a negative 7, it might be better to draw it on the negative side of the x-axis. But just for the sake of example here, because you're kind of like taking away area, you could like make this the same as the negative version of negative 7 to negative 1. And what happens here is that these two negatives cancel out. What you're left with is 1/3 of the integration of negative 7 to negative 1 du u. And when we take the integration of this, it will be ln u from negative 7 to negative 1. And this is where the second fundamental theorem of calculus comes in, where, actually no, I think this is just the first fundamental theorem of calculus, never mind. Okay, so this is what you substitute in the top, where you plug the top into the integrated value minus the bottom of it. Let's see if there's a better way to write it down. It's gonna be like, so if you take the integration of f of x, that'll give you big f of x, from a to b. Let's be from a to b, and this is the same thing as f of b minus f of a. And what this means is let's say like there's this, you're trying to check integration from a to b, and what we're trying to find is this value right here. This would be the big f of x. The line, the graph is f of x, and this would be big f of x. In order to find big f of x, you have to get the area from 0 to b, and the 0 is kind of implied because in that case the most of the values in the f of 0 will be equal to 0. So then you're trying to find this area over here from 0 to b minus this area over here, and you're just left with this leftover. It's kind of like the whole thing about change in time, where if you start from like 5 seconds to 10 seconds, what you do is you to find the value in between them, you just, even though it seems simple right now, just as like a rule of thumb, in order to find this area between here, you have to start from a starting point for both of them, which is, we'll just set to 0 because it's easier, and you go from this area, this time period, minus the time period where you aren't filming. So it'll be 10 minus this 5 over here. So it'll be 10 minus 5, which is 5. And the same thing over here. If you want to find the area between two endpoints, you find the total area minus the area, you find total area from 0 to the endpoint minus the area from 0 to the starting point. So in this case, it'll be 1/3 of the ln of the starting point, which is -1, or the natural log of the absolute value of -1, minus the natural log of the absolute value of -7. And let's simplify and just clear out the negative, clear out the absolute value. And this is what we have. What just remember to pay attention is that the natural log of 1 will always be 0, because in order to get a power of, in order to get e to the power of something to equal to 1, it'll always be 0. So it'll be 1/3 of 0 minus the natural log of 7. We simplify, and the answer we have here is the answer we have up here with b.